Today we're going to look at section 3.6, real numbers. Real numbers are rational and irrational numbers combined. The real numbers represent the collection of all physical distances that exist, along with zero and the negatives of those physical distances. Of course, if we name something the real numbers, there must be numbers that aren't real. One such not real number, one that cannot be a length, is the square root of -1. It is part of a collection of numbers called the complex numbers. It is denoted with the letter I. As an extension, the square root of any negative number is not a real number, but instead a complex number. So determine if each of the following are real numbers. 8 over 15 is a real number. How about 4 plus 17i? That is a complex number. And how about -17 times the square root of 46? That is a real number. So, the real numbers are built out of pieces including integers, rational numbers, and irrational numbers. As such, the real numbers have named subsets as shown in the table below. First, we have the natural numbers. We've talked about those, the counting numbers. We have a symbol for that. Then we have whole numbers, which is the counting numbers and zero. Then we have integers, the natural numbers, their negatives and zero. Then we have rational numbers, which are fractions of integers. Then we have the irrational numbers, that cannot be written as a fraction of integers. And then we have the real numbers, the union of the rational and irrational numbers, all possible physical lengths and their negatives. So, identify all the subsets of real numbers to which the following real numbers belong. So, if this is not a counting number or a natural number, not a whole number, not an integer, it is a rational number. And of course, it is a real number. I don't think it wants that. This here is an integer, a rational number, not irrational, and real. And this is rational and real. Real numbers behave in very regular ways. These behaviors are called the properties of real numbers. Knowing these properties helps when evaluating formulas, working with equations, or performing algebra. So we have this table below. Partial list of some of the properties of real numbers. First, we've already mentioned this earlier, is the distributive property. A times B plus C is the same as A times B plus A times C. Multiplication distributes across addition. Then we have the commutative property of addition. A plus B equals B plus B, or B plus A. Numbers can be added in any order. Then we have the commutative property of multiplication, which says A times B is the same as B times A. Numbers can be multiplied in any order. Then we have the associative property of addition. A plus B plus C in parentheses is the same as A plus B in parentheses plus C. Doesn't matter which pair of numbers is added first, as long as we're talking just addition or just subtraction or addition and subtraction. They're the same thing. Same with the associative property of multiplication. Doesn't matter which two numbers you multiply first. Then we have an additive identity. A plus 0 equals A. Any number plus 0 is the number. We have the multiplicative identity property. A times 1 equals A. Any number times 1 is a number. Then we have an additive inverse, which says A plus -A is 0. And we have the multiplicative inverse property, which is a times 1 over a equals 1 as long as a does not equal 0. So in each of the following, identify which property of real numbers is being applied. So what am I doing? 5 times 6 plus 19 equals 5 times 6 plus 5 times 19. This is distributive. We're distributing a 5. 4.7 plus negative 4, or 41.7 plus negative 41.7 equals 0. This is additive inverse. Okay. Use properties of real numbers and mental math to calculate the following. So we take 9 times, we can do, traditionally we do left from right. That's what I'm used to. So we take 9 times 8, which is 72, times 11, and we get 792. And that is the basics of real numbers. That finishes 3.6.